Greetings. My name is Isaac Johnson. I'm a Cloud Solutions Architect and Principal SRE Engineer at WellSky. This is my talk on open source and cloud for Open Source North 2023. It just makes sense. So the agenda today is we're going to cover cloud costs. We're going to level set on OpEx versus CapEx. We're going to talk about open source and platforms, languages, tooling, and more. We're going to look at some simple steps to minimize and restrain costs in the cloud, including covering things like budgets, CUDs, and RIs. And we're going to talk about open source tools for measuring, monitoring, and mitigating cloud spend. First, let's talk about CapEx versus OpEx. We throw these terms around a lot, but we need to understand them. So CapEx, or capital expenditures, is purchasing equipment, hardware, laptops, equipment for the network operations center, etc. And when you have CapEx, you're subject to amortization and depreciation. So with amortization, it means if I buy a $5,000 server and I plan to use it for 5 years, I can say it's $1,000 against my budget each year. And depreciation is that acknowledgement that at the end of 5 years, it's not worth $5,000. It's probably not even worth anything. I got to pay to delete it, or destroy it. So we depreciate that value over time. It's like buying a house, right? When you buy a house, you have to pay for its roof and you have to pay for, water problems and everything else. It's the care and feeding. It's very much a pet. OpEx, or operational expenditures, more like managing the NOC. It's like SaaS offerings like Office 365, anything that you pay for the usage of, but you don't own. I don't own GitHub, but I might pay to use certain features in GitHub for GitHub Enterprise. It's like renting a house. You pay the electric bill and the gas bill, but you don't own the house. You don't have to deal with the roof. You don't have to deal a lot of times with the lawn. Sometimes you do. But it's the renting of a house. You are just paying for what you use, but at the end of the day, you don't own any asset. And cloud is all about moving from CapEx to OpEx, for paying what you use, not dealing with amortization and depreciation. I can recall back at TurboTax, as we were moving out from on-prem to the cloud, the biggest reason is the product, by and large, used one time a year, and the rest of the year, not so much. And so we were often having a huge amount of servers that would depreciate that we'd have to cycle out just for one big initiative a year. And so it's a great for scaling very large, but when you scale small, you don't need to pay for it. The cloud is more secure. Your team may not be the experts on how to secure your network perimeter or all the things you need to do in a data center, but Amazon is, Azure, Microsoft is, Google is. So having these cloud vendors, they secure the cloud. They often talk about they secure the cloud, but you secure the data in the cloud. And lastly, if you do things with open source, you have the ability to move cloud vendors. You don't have vendor lock-in. So picking open source technologies enables us to have choices and avoid vendor lock-in. So let's talk about the big picture. Where does open source fit within the cloud? So first we're going to kind of cover the platform. Things like operating systems, Red Hat Enterprise Linux versus Windows servers, Core OS, Ubuntu, and other Linux. We'll talk about language. We're going to pick on Oracle Java for a little bit, but it's one language we can talk about. We're going to talk about provisioning and infrastructure as code. We're going to talk about Tower versus AWX and speak on Terraform. And lastly, we're going to cover monitoring and control, looking at things like OpenCost, KubeCost, Cast AI, and Cloud Custodian. So languages and platforms. Let's talk about the kind of operating system frameworks and infrastructure as code. And the first thing I'm going to talk about is the languages aspect, Java. And since not everybody, is a programmer, Java came out in 1995. Sun introduced Java in 1995. And in 2000, I'll be obviously speaking at Open Source North at University of St. Thomas, so I'll speak to it here at UST. I was there when they kind of moved over from Pascal and C++ to Java in 2001. In 2006, Sun GPL Java with GPL 2.0. Its initial release was May 8th, 2007. In 2009, Oracle bought Sun. And MySQL shot off to MariaDB. Hudson forked off to Jenkins when Oracle said that they'd make them pay to have the name Hudson for HudsonCon. I can recall working at a small startup then that MySQL Enterprise tripled in cost overnight for the licensing. We had to do a big initiative to move to Postgres. In 2018, the Java 11 release, they changed the restrictive licensing on the JDF, which meant that you might have to pay extra licensing if you're using it to make money. In 2019, They made a change. Everybody was still using Java 1.8. It was a very stable platform. You had to pay a business subscription if you wanted to get security updates, which was a huge deal. In 2021, they said, oh, it's free again for commercial use, but there's a reason I put the ellipse there. So let's do a case study on Oracle, right? In 2020, Oracle Java still was 75% of all JDK distributions. But by 22, Oracle only had 34.48%. What made it drop in terms of platform adoption? Why did people start using other JDKs? I mean, obviously, as a language, it's still used by 33% of developers, according to a Statista survey in 2022. On the left, we talk about Oracle JDK. The cost of Oracle JDK 14 licensing for 100 developers was almost $29,000 a year. At times, Java Standard Edition is $5,000 a year per server processor, $1,100 support fee per processor, $110 per named user, 22 annual support. New Standard Edition plans are $25 a month per processor, including any clouds. If you have a Lambda, that's a processor. $2.50 per user, then $15 a month an employee, and volume customers are over 50,000. And then they made a big change that said Standard Edition Advanced Desktop is $40 per named user plus. And what's a NUP? A NUP is any user plus any system account that might run Java. You have to pay for that. And $100 a NUP in Standard Edition Suite at $300 a NUP. In January 2023, that was the ellipse, they changed it again to per employee, including all part-times and temps. So companies that might be 25 on-prem employees, but say 225 remote employees, working in a low-cost center, all of a sudden they went from $3,000 a year to $45,000 a year in licensing costs. Whereas OpenJDK is built and supported by cloud vendors. You have robust binaries from Amazon, Azure, others. If you don't know Azure, if you launch something with Java on AKS, it's probably Azure Java. The license cost for 10 developers is free. The license cost for 10,000 developers is free. The license cost for 10 million developers is free. What you pay for is the cost for support, and it varies by vendor. If I look at savings from Azure, 100 cores, 100 desktops, 100 employees might be 14 grand. If I look at the cost of paying for support from Red Hat, it might be $15 a month for a single user, all the way up to $1,250 a month for 100 users. But maybe I'm only paying for that for my production Java, or once I've reached production and we have income coming in. I'm not paying for it otherwise. And if I stop paying, if I decide I don't need it, I still get the security updates. I still get the binaries. So on languages, using Java as an example, language vendors like Oracle can change licensing terms often with huge impacts to annual costs. Tying into specific vendors' implementation can create vendor lock-in. It limits the kind and cost of developers you can hire and the creative solutions they can apply. If I am married into Oracle Java, I can say that every developer I hire has to be Oracle Java certified. That's not going to be a lot of kids coming out of college. And sorry, I'm an old man, so calling them kids. But people coming out of college. Open source language providers like Azure and Red Hat have great value adds. So if we are in production and we want to be able to call a phone number at night or send an email when we're having troubles, we can pay for those licensing. They have a value add. Let's talk about Docker. A lesson on what not to do. So the short, happy life of Docker Swarm Enterprise. All right, in 2013, Docker was released. It was born into the world with PyCon 2013 in the first demo. In 2014, Docker Swarm was first introduced. It was part of the Docker Enterprise Support 1.0, June 2014. In 2016, Docker Swarm Mode is free, but all the parts you need to actually use it cost money. So the Docker Trusted Registry, DTR, and the Universal Control Plane, UCP, required licensing. In 2019, Docker Swarm was sold to, and Enterprise was sold to Mirantis and shuttered almost immediately. So what happened? Well, 2014, Google introduced Kubernetes coming out of Google Borg. And we can then see that they're trying to react. So in 2017, Docker integrates Swarm with Docker Enterprise Edition, but it's kind of too little too late. If we're looking at the Google Trends as far as searches, we can see the red line for Kubernetes. By 2017, people are searching for Kubernetes. They're not searching so much for Docker Swarm. If we look at Google Trends, the interest in YouTube over time, we see a very precipitous change around 2017 as Kubernetes kind of takes off and Docker Swarm goes nowhere. If we look at GitHub questions and stars, these are repos and people's feedback. Developers right? I see a steady increase from 2015 on for Kubernetes, whereas Mesos and Docker Swarm kind of stay down there. Another reason this happened is we got to think about the cloud providers. So 2014, when Docker Swarm's coming out, Azure, Microsoft hires up Brendan Burns to help create Kubernetes, and you get Azure Kubernetes Service, AKS. 2015, Google themselves follows suit. They create their own Google Kubernetes engine offering, GKE, in 2015. And Amazon, who kind of bet on the wrong pony, they picked the HD DVD while everybody else picked Blu-ray. They kind of admit defeat and come out in 2018 with the Amazon EKS, Elastic Kubernetes Service. We see that HPE stopped their sale of Docker Swarm with the sale to Mirantis in 2019. And AWS held on. They're the longest. They kept their AWS managed Swarm instance available all the way up till January of 2023, just this past January. If we look at the real reason open source won here, Josh Burkus of Red Hat Kubernetes said Swarm was not a production solution because it had no feature for plugging into cloud storage in a reliable, repeatable way. You only had one vendor really supporting building out Docker Swarm. All the clouds were in Kubernetes by 2018. And the CNCF was and is strong. If we look at it, this logo foo is crazy in terms of active Kubernetes platforms you can get that have been CNCF certified. In fact, there are so many of them, I decided to create a little graph of it. These are the number of certified distributions per version of Kubernetes. So the most active one is Kubernetes 1.24 Stargazer, which was released in May of 2022, has 108 CNC certified distributions. And back when I wrote this presentation, 1.27, only 3 weeks old, already had 9 certified CNCF distributions. So our operating systems. So Windows might be the dominant OS, but with Windows 10 comes WSL, Windows Subsystem for Linux. A Stack Overflow 2022 survey found that 15% of developers use WSL and 40% just use Linux. We have 31% on Mac and 62% using Windows. This graph is really meant to illustrate that Windows 10 and 11 have taken off, right? Windows 7 is barely there on the graph and the others have gone off the radar. Windows 8 and Windows XP are all but gone. So we have Windows 10 and Windows 11. And what I want to point out is using Windows Subsystem for Linux is really easy. So here's a little demo of what WSL looks like for those that don't know. So I'm on my Windows box. I can launch an Ubuntu shell right away. In fact, installing Ubuntu was just a marketplace option. So now I have this full Hyper-V running Ubuntu. And with Windows 11, we get an Xserve. So now I am launching Firefox in Linux, graphical app, onto my desktop. And what we can see here is Edge running on the same host as Firefox and Linux. They both are sharing space. And on the left-hand side, we see all the graphical apps that I might install in Linux, like Firefox or ImageMagick or OpenJDK. They all have a way to launch into Xserve on Windows. If we look at market trends of supercomputers, essentially up through the 90s, I mean, back when I was at Control Data, we still had choices for supercomputers. But now that we're by 2013, they're all Linux. I mean, all the supercomputers are Linux. If we look at computers in K through 12, and I won't dig into this, but the key thing that I want to point out is one of the results of COVID-19 was that our students now, by and large, all have laptops and compute. And so by 2020, we have 66% of high schoolers and 69% of middle schoolers, and Chrome OS is definitely a big option, or Windows with Windows Subsystem for Linux. We see with Chrome OS Flex 2022, any device can be added as a Chrome OS device. Schools can reuse their hardware to use Chrome OS, as long as you have 4 gigs of RAM and 16 gigs of storage. Our top containers, a report by Datadog showed that all the top containers are all open source. Every single one of them, from Nginx to RabbitMQ to Vault, they're all open sourced containers. So what's my point? All current operating systems either have Linux underpinnings, like Mac OS with their terminal, which is BSD based, or Linux as an option, WSL. Most browsers are open source. They're either based on Chromium or Firefox. Almost all current supercomputers are Linux based, and the top containers are all based on open source projects. In other words, open source is the operating system. What happened to Core OS? I mean, I got t-shirts of them up in my closet. They were going to be the big thing. Well, if we look back at Linux distributions, and CoreOS, if you're not clear, was a commercial Linux distribution. Red Hat sales hit $1 billion in 2010. And in 2019, Red Hat was sold off to IBM, and the key reason was OpenShift. But CoreOS was part of that offering. If we look at before, in 2016, there's no CoreOS, Ubuntu, Debian, CentOS. And if we look at 2023, again, CoreOS isn't even there. There's like no blip on the radar. If we look at CoreOS from the Red Hat page, it says it was founded in 2013 for security and reliability. Red Hat acquired them in 2018 with big plans for the project, and in 2020, it's no longer alive and it's dead. If you look at CoreOS, because they did have a container side in Docker Hub, you'll find that it hasn't been touched in 7 years. And if you look at the cost of Red Hat, if we don't even consider CoreOS, but just Red Hat Enterprise Linux, in 2010, it was $180 a year. And now it's $400 a year for licensing for Red Hat Enterprise Linux. OpenShift is presently $2,000 a node for licensing. If you go look up CoreOS, you're going to find people pointing you to Flatcar. And Flatcar Container Linux, which is open source, is a very locked down, secure version of Linux. And you can find instructions on even how to migrate from CoreOS into Flatcar. But what's key to know is, besides having active channels and is actively supported, there are no Docker images. Flatcar is just Linux OS for VMs, okay? But what's neat here is what you can see is it doesn't cost anything. It's $0 an hour here for the licensing. And if I go down to Google Cloud, at the bottom there, $0 a licensing. AWS, $0 a licensing. So I have a way to launch a secure Linux that is actively supported that doesn't cost me anything for licensing, just the infrastructure. My point here is when you look at operating systems and container providers and orchestrators, if you do a single vendor non-open source, they can be sold off and shuttered, and you're stuck with that. You can have a slow creep up in prices, just for licensing. It limits your hiring option. You got lock into one OS, you're like, well, we got to use CoreOS, we bought it. And the long-term technical debt, you're going to have to deal with those things eventually. Open source is alive and maintained. It's community-backed. There's commercial offerings for support and value adds. We kind of talked about that with Red Hat and Azure. And we have increased innovation hiring options. Let's talk about provisioning in IAC. First of all, let's talk about Ansible and AWX. And my last talks were kind of negative. I had to talk about how things didn't go so well. This is a positive one. This is fun to talk about. Ansible and AWX is a positive case in point. So Ansible came from Ansible Works, developed by Michael DeHaan, who did Cobbler, and Timothy Guerrilla. In 2015, Red Hat acquired them for $100 million, but they had committed to open sourcing it. So they honored that commitment. In 2017, they launched the AWX project to open source Ansible Tower. In 2019, Red Hat kind of changed things up. Tower became Ansible Automation Platform. And I used to think that they were just doing some marketing, but they didn't. They basically took Ansible Tower, the Ansible engine, and the Red Hat network automation and bundled them as a larger offering. This is about the same time that IBM bought Red Hat. In 2022, Red Hat launched the Ansible Automation Platform in AWS at an Azure Marketplace. And in 2023, just this year, it's in the GCP Marketplace. Now, if we look at orchestration tooling, and I like to think about Chef, Salt, and Puppet, and Ansible in kind of the same venue. A JetBrains survey in 2019 said 27% of people hacked their own thing, and 43% said none. But if we take those out of the picture, Ansible had the most, 23% according to the JetBrains survey. And Puppet had 9%, Chef had 8%, Salt had 4%. The quote there is, we found that Chef and Puppet have similar market shares this year, but their combined market share is still slightly lower than the market share of Ansible. Another survey from Data Analyze, I really am sorry, I can't pronounce their name. We can see that Ansible had 24.33% and Terraform at 21%. And basically, if you look at other surveys, depending on which part of their reporting you do, Ansible is as high as 34%. Puppet held on to 15%. It's the number 2. Salt, I mixed both Salt and Salt Stack because they're reported separately, but I think of them as the same. Salt's about 10%, or 14%, sorry. And Chef is near the bottom. Chef didn't even rate it. It's at 0.1%. 48 sites in total reported that they use Chef still. I like to call out when I use AI. I asked AI to kind of help compare these. And why was Ansible the biggest pick? According to the AI Bard, it's easiest to use. It's the fastest. And the part I really agree about, it's got the largest and most active community support. I mean, it matters where you can find recipes. And it's very flexible. Now, another thing to point out is who's championing these things. Puppet was its own company. I still have stickers on my laptop. Perforce bought them. So Perforce made Perforce the revision control system. And as Perforce kind of lost market share to Git really took over, they expanded their portfolio to have a lot of different tools. So now Perforce is a company that would say they're not a source code tool company. They're an enablement company with lots of products, right? So Pup is just one piece of it. Progress, whose main product was called Progress, made like a business appy thing. They bought Chef to kind of expand their portfolio. So they're a company of a lot of different things. And I'd argue IBM, who bought Red Hat, Ansible is just part of the equation, but Red Hat has really done a lot of care and feeding to it. Now, if we kind of compare these two, well, how does Tower compare to AWX? Sorry, I keep using the word Tower. I should say AAP, but I'm going to call it Tower. How does Tower compare to AWX? Well, if I log in and look at job status, they're practically the same. You know, host, failed inventories, they're all lined up across the top. If I look at the instrumentation, the templates, you know, running a job, left is Tower, right is my AWX. They're the same, practically the same. If we look at the login page uses the same photo from a cool architectural building in Seoul, Korea. It's the same, right? But there is a difference. If we go to AAP, we're going to find that there's a lot of value adds. We can see that they support the cross-pollination and feeding with the open source group. We have cluster management in the upper left. We have trigger jobs. We have collections, and we have portfolios, and we have Red Hat certified content with 18 months of support lifecycle. And what Red Hat would argue is go use AWX. It's solid. It's the underpinnings for AAP. But if you want a hardened and functional out-of-the-box server, buy AAP. If you want to do things across your enterprise, use AAP. They add value to it. And so in this case, we have this super solid, super active, fundamental core thing of Ansible and AWX, but we also have an option if you're a company that just wants to buy a thing. So about Terraform, and I didn't have a good slogan. I just called it best in class because I do think it is. So if we look at this slide of Terraform, and by the way, I pwned myself because I didn't find Packer on here, and Packer's, I think, an important one of their products. But what we see is console for bridging the network. We have Nomad for deploying containers and deploying things, Vault for secrets, and Terraform is for provisioning, right? And Vagrant will install VMs, the Vagrant service. Terraform is open source and active. It's free to use in every way. There's a large active community providing modules. I mean, it supports all the clouds and many on-prem. So big IP F5s, VMware supported. It supports many other tools, Datadog. We use it for New Relic for launching some of our monitors. It works on most OSs with a simple binary. And just to give an example of usage, you know, here's an example of me using Terraform that I've used this one a lot to create a resource group and a storage account with a 30 gig quota, right? So I want to run it, right? So Terraform, I can run Terraform and say Azure DevOps or GitHub. You know, both of them can have main TF. But I can also use Terraform Cloud. And Terraform Cloud, you can even use things like the open policy agent. So open support in there with Regos. So here's some restrictions I want to do, as well as Sentinel. And if you need that next level, you can do Terraform Enterprise. So I masked a lot of things because I can't afford Terraform Enterprise, but we use it as a business because we need that kind of big support to orchestrate Terraform over many places. We don't want many different Terraform cloud instances. We want the control for that kind of big project. My only thing I might pick on Hashi about is they keep changing the gosh darn model. So now they have free for up to 500 resources a month. It used to be free for unlimited. And then they have standard now, starting at a fraction of a cent per hour for resources. And the first 500 resources are free, so it's free, and then we'll pay. You got to pay if you want to use more. They have Plus and they have Enterprise, which are always contact sales. Let's talk about minimizing cloud costs. All right, I want to talk about RIs, CUDs, and SUDs. So Amazon and Azure will talk about reserved instances. They're discounted from a month to a year in the case of Azure, from 1 to 3 years in AWS. We have, with AWS, a little bit more nuance between standard and convertible. Convertible means I can use it for more than just the machine class, whereas standard is rather locked into a machine class. And GCP has the idea of sustained usage discounts, which mean if you just keep running it, you automatically get a discount. Whereas you have CUDs, or committed use discount, which means if you just want to pay for something up front, this is what it costs. And one of the things that I wanted to point out is they almost all have a maximum discount of 75%, 72, 75%. I should point out, if you're a business that uses Azure Hybrid, those hybrid costs, you can save some money by bringing your Windows Server licenses over to Azure. So if you're a Windows shop, there is some extra savings you get if you're using Windows hosts. So I want to do like a compare cloud costs. Let's look at just 2 CPU, 8 gigs of memory host, right, with some Git disk. So with AWS, that might be an M5 large, GCP an N1 standard 2, and Azure would be a standard D2S v3. So if I kind of look at these costs, we'll see that monthly, this is 730 hours, right? AWS, just paying out of pocket, would be $70. If I want to get an EBS volume, that's $80. Azure is $92.71, but does include a 14 gig disk. GCP is $48, but if you add in their storage, that's $16. That brings it up to $64.54. And I bring this up because it's worth considering these non-big three. Akamai Linode for a D4.8G is $48, and that includes 160 gigs of disk, a nice big old disk. If I pay for a year up front with AWS, that's $51 if I want convertible, and $43 if I say I only want that machine class, only M5s. With Azure, you come down a little bit to $80.29. And with GCP, I actually go up to $69.36. That is, the discount in a SUD is more than the discount of a CUD. And in Akamai, that's still $48. We're happy with the $48. 3 years, we can get all the way down to $35.87 in AWS. That's convertible. And if we lock ourselves into F5 or M5, that's $29.93. That's a big savings, Azure, we come down to $63, again, paying up front. And with GCP, it's $52, and that's a 46% discount. Akamai still happy with their $48. It's that whole CUD SUD. So when we asked, and I was researching this up, US Central, $69.35 a month with a 1-year discount. But if I'm looking at the cost table for the percentages, over 75%, I'm at $48.45 a month. It's cheaper to just let it run if I know I'm going to run it all the time in GCP. Again, I get charged per month, not per second. Here's the free tier. I want to talk about this. F1 micros are free. It's 30 gigs of disk, a gig of bandwidth, 1 CPU. It's 1 VM, so you get like an instance per month of GCP. With AWS, it's 750 hours. You could have a few different T2 micros. With Azure, it's a B1S burstable. 750 hours, doesn't matter how many instances, just 750 hours total, which is a month. And when I went to do this demo of a free tier, and I'll let it run for a few, and I went to create it, what you'll notice is you can look for free services. So if you search for free services in Azure, you go, great, oh look, it's a B1S. That's free, I love it. I'm gonna go ahead and create one of those, right? I click the create button. As I was doing this, I launched into the compute wizard. I'll go ahead and create a new resource group. This is fine, but I hope you're noticing the size there is not a B1S. In fact, you can't find the B1S. I see a standard D2S V3, and that's $70 a month. I'm going to keep going here and create a password, right? It's a little more restrictive, so got to use a more complicated password than I might do normally. And then I can go ahead and do next. And what this is going to do is I'll walk through it and at least go as far as where the guide shows the costs. But I'm not getting a free instance, I'm getting a Linux instance that is right here. You're going to see the cost is 9.6 cents an hour. So it's not free. So why is that? Because almost every one of these clouds, as you look at them on these free services, they're always with this asterisk for the first year. So Amazon, there's a free tier for the first year. For Azure, there's a free tier for the first year. GCP for the first year. So you start using the cloud for more than a year like I have, all these free compute has gone away. There's none of them available to me anymore. Let's go on to talking about alternate clouds. So Civo is one of my favorite ones. They come out of the UK. You can get a Civo extra small for $5 a month with a terabyte of transfer and a pretty fast 25 gig NVMe. If we look at Akamai Cloud, used to be called Linode, you can get a Nanode for $5 a month. Again, cheap and easy. I use them all the time. And Alley Cloud's fun. I just like Alley Cloud because they make me laugh. They always do fun things. Here we have like different versions. You get discounts on renewals, and so you get a lot of free stuff, but then you just gotta pay attention to canceling it later. And then I also want to bring up Ivan. Ivan is a company out of Finland that does cloud offerings, and they only do open source projects. So they have like OpenSearch or InfluxDB or Grafana. You can launch for cheap. You just pay for the compute. They're not charging you for the licensing. It's a very legitimately inexpensive service. And they have a bunch of free plans. They have a Redis, MySQL, and Postgres. Now, they're small classes. They're not super performant. But if I need to spin up a very quick Postgres server in the cloud and know that it's just going to work, I can do the free plan of Ivan, and it'll work just fine. Let's talk about budgets. So cost alerts from the cloud. So my general rule of thumb when it comes to budgeting is at 20%, you should probably notify parties of persisting spend. At 50% is a good time to start to alert, hey, you spent half your budget. And at 95%, you better start disabling things. So if we look at budgets in Azure, you can see that I can create this new budget, give it a name. I can give a create date and expiry date if I want, and what the amount is. So I might set mine for $20. And then what I do is I can say, give me an alert. And one of the things I'm pointing out here is you can send things to like the email address of PagerDuty to trigger an alert when you've hit your threshold. One of the features I discovered while doing this that I wasn't even aware of, must be relatively new, is the anomaly detection option out of the pay-as-you-go. So I can say, if you see something weird, why don't you email me? Just an anomaly, and I like that. And of course, you can do the email integration with PagerDuty to trigger out email alerts. So here's budgets in GCP. So what I can do here is go to budgets and alerts. And once I go there, you can see that I have already some here. So I have one for Google Maps. I used to do some apps for the Pebble Watch that use the Maps API, and I kind of wanted to make sure I didn't go nuts if people used it a bunch. And so I have some alerts here with a target amount, just so I get alerted before my wife thumped me. So that sends out alerts to the admins. And then the other one is I can do a budget here. And what I would do with this one is pick all my projects. So make sure that I trigger an alert on all the projects. And I can set the threshold for something like $20. That looks like only 1 month did I leave something on that I would have been alerted. You can see things for different levels, 50, 90, 100% of budget. And it gives you that amount just as an example. And then you can say forecasted or actual. And lastly, you can do actions. So what you can see here is I can send emails. I can also connect it to a pub subtopic. So I have Dapper connected to my different pub subs. So I can do all sorts of fun stuff with Dapper to trigger other alerting and notifications and automation. When it comes to monitoring, you can pick other projects. One thing that I'm going to point out in picking these projects is when you go to manage notification channels, you're going to see that I already set up PagerDuty, but it didn't show that as an option. And part of the reason there is that it's only going to show email channels. And that's okay, because we can go into PagerDuty, log in here, find our service, and it's okay because I disable this one later. I don't mind showing you the email. We'll go over to services, so we'll find a service that's going on. I'll find my cost alerts. We see it's in an alert at the moment. I'll go to integrations, and what you want to do is you want to add another integration and add email. So email is the integration that's going to trigger an alert. So you do email, save it, and it's going to give you an email address that if you email that address, it's going to send things into an alert status. And in my case, email my phone, text me, etc. Whoever's on the on-call rotation. And so I can add that email alert channel here in the budget and go ahead and set that back in my budget. So I'm going to go back to the budget window Now when I refresh, I can pick PagerDuty as something that I send an alert to, which is awfully handy. And what does that look like? I set it to like $1 so I could see what it looks like. Here you can see Google Cloud reach 100% of budget. I get a nice email, but at the same time, PagerDuty went off. And PagerDuty went off. I don't know, it sent it 3 times, so you would definitely be woken up by an exceeding bill. So about monitors. Yeah, can't manage what you don't monitor. So I'm going to look at KubeCost, OpenCost, CastAI, and Ternary. So KubeCost was the first that open sourced OpenCost, and I more recently have looked at CastAI, and Ternary is just a commercial offering, but I want to show you options. So OpenCost. OpenCost is it just shows you reports, right? So here we can see that it launched a Prometheus agent. It shows me where my different spend is on my demo cluster. I can see nodes usage, so I can see the different nodes and how much they're using up of resources. But what's kind of cool is I pointed OpenCost over to the Prometheus running under my KubeCost namespace, because I've been running KubeCost for several weeks. And I just love the fact that OpenCost was able to consume all the metrics straight out the bat. I used the same login credentials, even the same settings to my Helm deployment. And OpenCost now had 2 weeks of data. So I don't need to have a Prometheus per instance. I can use both KubeCost and OpenCost together. And obviously you can see here the calculated cost based on the CPU, RAM, etc. If I was to pay GCP prices, what it would run, because it does use the GCP API in the background for cost calculation. You can change that, by the way. What's kind of neat is as I look at things, I can dump it to a CSV. I didn't show you, but that little right-hand arrow, so if we look over here at this right-hand arrow here, that'll dump it over to CSV. And so I could dump it to CSV, bring it into Excel, and show what is the pods per CPU usage. The other thing is I could look at the cost is calculated by release. So here I can see that KubeCost is actually costing me the most, logically. I mean, these are on-prem servers, so I'm not paying anything, but the most expensive. OpenCost also has an API. So as you can imagine, if you have a RESTful API, you can have fun. So you can do things like go ask for all the resolution by a minute of a namespace and calculate the cost. And I can start, now that I have all this data, I can do things with it, trigger alerts, alarms, reports, etc. KubeCost is similar. So if we look at KubeCost, we'll see that it calculates all the prices, but also shows efficiency. On the right-hand side here, we can see like savings it finds, right sizing your cluster nodes. What are your underutilized nodes? Right sizing your container requests, using reserved instances. It can give you a lot of feedback as far as cost savings. It's going to talk about right sizing the cluster. So it says this is your recommended. You really ought to be using something that's 2 CPU and 1 gig of RAM instead. And in my case, use a B1LS as the machine class. It talked about nodes with underutilized CPU and memory. So I was looking at Azure Kubernetes service and found one node was safe to drain. And you're like, well, how did you come to that conclusion? Well, to tell you, if you click it, it says, well, a node turnout will not break any PDBs, right? No pod disruption budgets. There's no pods with local storage detected. No pods annotated as unsafe to delete. So it did all the checks you'd want to do as a safety check before you took down a node. I like that feature. It's a little value add. It found all the abandoned workloads, things that haven't been touched in a long amount of time. I have an old waypoint server that could be gone away, things like that, or Hello World Golang app that I could tear down. You can also send alerts. And now we start to get into some of the, KubeCost has a community edition, a free tier, but has a commercial offering. As you get to more alerts and reports, that's where you start to get to the commercial offering side of the house. CastAI, very similar, very pretty graph, monitoring all my cloud spend. Here it's looking at a cluster and the total cost and spend per day. It can look up all the deployments going on here and give a nice generated breakdown of different costs. One of the things I liked is it could do a forecast. When I launched a new Azure Kubernetes service and I gave it more than a day, I'm not willing to spend more than $10 for a blog post. But when I was doing this for a blog post and calculating it up, you can see that it was actually pretty close. According to my calculations, I was looking at $188 for the month for that cluster, and they suggested about $181. So very dead on as far as cost suggestions. CastAI has the option of a smart node pool where it can do intelligence to determine workloads that can be gotten rid of and reducing nodes. I couldn't get it to work, but I don't think I was doing it quite right, so I'll believe that can work. Lastly, let's look at ternary apps. So here's a ternary app. We use Ternary. It's a commercial offering for monitoring cloud costs. One of the nice things that you see here is it can monitor all the things from your VMware engine to your Elastic Cloud to disks, things beyond just Kubernetes. And it can give you recommendations. So here it's suggesting a node pool that might be able to be changed. And we can look at our costs up and down from forecast. Did we meet our budget? Did we exceed our budget? Let's talk about mitigation. So we've talked about ways to try to reduce it, but now it's time to terminate and destroy. So the big name in the game is Cloud Custodian, right? I think that's one we've all used, maybe we all know about. We create a policy, we can define rules for our environment, and then we run Cloud Custodian, and then we can refine and improve policies. So here's an example of a policy to to tag VMs. So there's a hello world tag, and we can see if I run it, it would go ahead and not touch this one, but the one that matched the name adds the hello world tag. Let's do another one for VMSs that do not have a hello tag. Delete them. So I tagged 2 virtual machine scale sets so that they were fine. What you're going to see here, it's a much sped up recording, is that I create a virtual machine scale set. I'm going to create a new resource group. But what I'm going to do here is after I give it a name, then I'm going to say use spot instances to save some money. And I'm also going to change the instance count to 0 because I don't like it to kick them up to start with. I'm going to move on here to the tags, and when I get to tags, I am not going to give it the hello tag. I'm going to give it not hello. I'm going to not give it the required tag that it now requires for Cloud Custodian. So you see it move on. It's going to create this instance. And these Cloud Custodian works with all the clouds. I use Azure just because I know it better. But it would work in GCP and AWS as well. We deploy. And what you'll see me do is I'm going to run this thing on a laptop. So I'm going to run Cloud Custodian on a VM. It could obviously be run in a container and other things. So here we see our virtual machine scale set. Oh, I got to type that the right way. Scale set. And I'll see that I have 3. 2 of them I tagged properly, but the new one that's in the middle, this is a test RG, I did not give the right label or tag. So I now run Cloud Custodian with that policy I showed you that says delete them if the hello tag is absent. We see that it runs and it's done. If I refresh it, I don't immediately see that it's gone. But if I go ahead and click on it, what you'll see happen is Azure's going to tell me there's no such resource. So I click on it, not found. It's gone. If I want to be sure of it, what I can do is go over to the resource group. And if I give it a beat and refresh, what you'll see is that virtual machine scale set goes away. So let's talk about automating. Like I ran a thing, but you wouldn't want somebody whose job it is to click the button every day. You could do it with Azure DevOps on the left with a nice automation pipeline. I actually have one of these running. On the right is one that I was setting up in Ansible to run in AWX. And if you're doing things like Azure DevOps, you can do things like a schedule. So here I'm running it at 1 a.m. every day to clean up anything I don't want. Other ways you can save money is using TIMP accounts or sandbox accounts. So VSE is a common choice. Visual Studio Enterprise used to be called MSDN. You get $150 a month. And there's different levels, $100 for MSDN platforms, $50 for VS Professional and VS Test. And presently to get a new VSE account is $6,000 a month or $2,600 to renew it. Luckily my employer does it. I don't pay that cost. But you wouldn't do it just for the cloud credits, but it's a nice benefit if you have VSE. So what happens is if I overspend that $150, it tells you your services were disabled. And if I have the power, which I do, I could remove the spending limit, but by default just shuts things off and won't let me create more. And then at the first of the month says, hey, congratulations, you can start using Azure again. We've re-enabled your subscription, so great. Our company and other companies I've worked at too have had this kind of thing where you have a dev portal where you can create a sandbox account for 1 to 30 days. I think it's a great way for POCs and demos. So if we do this at WellSky, like this by default was 7 days, it would delete the project when it's done. And it was our cloud team that built this. So account policies. I'm going to look at Azure, though this is true on AWS and GCP. With Azure and policy management, I can either say not allowed types or allowed types. So I'm going to go with not allowed. When I do the not allowed policy, we can see the specifics, but then what I can do is when I invoke it is say, we're going to apply this on a subscription and optionally a resource group. So maybe I had a team using a resource group that I gave them specific access to just a resource group through IAM policies. And so I'm going to control what they can do in that resource group if I wanted to. Otherwise, you can do it just to the whole subscription. And you can pick anything you want. So in here, I can see things like virtual machine scale sets. Maybe I want to make it so that I pick the last button there on the list and they can't make VMSSs. I should point out with remediation, by default, it only takes effect in newly created resources. So existing ones aren't sorted out until you do a remediation task. So just make sure that you know that these would affect things going forward by default. In summary, I covered a lot of stuff, so let's talk about it. Open source platforms. Linux's queen has given birth to so many amazing things. Use Kubernetes. We talked about that with Docker Swarm, and keep with active operating open source containers. As far as open source languages, we talked about you can experiment, but stick to GPL and OS programming languages. This is where we compared things like Java. Open source provisioning and ISC, tooling like AWX and Terraform are great that do have commercial offerings on top of their open source platforms. And look for stable OS platforms with commercial value adds and support. As far as cloud offerings, think critically of value. Look for the free tier, but don't bank on it, doesn't last. And consider the non-big three clouds. As far as budgets and monitors, you need to measure and report. Use cloud budgets for alerting. That's what they're there for. And use open source tools like OpenCost to monitor things. As far as mitigation goes, we kind of did a deep dive there with Cloud Custodian. And also think about using things like Visual Studio Enterprise and temporary learning accounts so that you don't have to worry about your persisting cloud accounts, that you can use temp ones that get deleted up. And lastly, you can use policies on your various cloud providers to limit what people can create. I want to thank you for your time and sticking with me all the way to the end. It was a long presentation. My email is there, and I don't use Twitter, but I'm on Mastodon at NOC Social, and you can see my active blog at freshbrew.science. Thank you so much, and have a great day.